next event, which is a very, very interesting panel discussion, shaping the future of semiconductors in India. And I think, talking about so many aspects like we just spoke about in terms of, what semiconductors would be like, programmable platforms, 5G, the role of networking. I think this is a very exciting time for India, but also with a lot of challenges. So, I think it's going to be a very, very interesting panel discussion. And a little housekeeping announcement: after our panel discussion, our audience will be broken into 4 parallel tracks, into the Grand Pavilion, Auditorium 2, Auditorium 3, and Auditorium 4 for technical paper presentation sessions. So, with that, I would like to now go back to our panel discussion and welcome Mr. Nirmal John. I was just reading his bio, and it was just so fascinating to see all this interest that he has. And I'm sure this panel discussion would turn out to be super interesting. Nirmal likes to observe and write about the intersection of technology and people. Making complex conversations democratic is what he believes in. He is interested in the evolving conversations around the future of media, technology for everyone, geopolitics of technology, ethics in AI, space, civil liberties, futurism, urban evolution, advertising of tomorrow, cycling, and football. Did you leave anything out, Nirmal? First, a book by Nirmal, Breach, a remarkable stories of espionage and data theft and the fight to keep secrets safe, was published by Penguin Random House in 2018. He is a Chevening Cybersecurity Fellow and the recipient of 2016 Prize for Economic Journalism in Asia, awarded by the IE Business School in Madrid, Spain. Mr. Nirmal, I'm more than pleased to hand the baton on to you for the panel discussion.
Thank you so much, Shweta, and thank you for having me, all of you. I think it's a pleasure to be here, and it's a very important topic also, right? It's very relevant to the times. The way I see it, 2021 was transformational for the narrative around semiconductors in India. It was not something that was discussed by us in the media much. I mean, except in the odd occasion when there was a policy announcement or an innovation around semiconductors. But I think the semiconductor shortage changed all of that. We at ET Prime, have been covering the impact of the shortage, and we've been asking a bunch of critical questions around how India should be looking at this sector. I think it's fair to say that there is much clearer understanding of the strategic importance, both in terms of geopolitics and a geostrategic and a geoeconomic standpoint, that we have at the moment around semiconductors. But what is quite sad is that we needed a crisis to remind us of this. We needed a crisis to push us into action. But I guess better late than never, right? So I think that's where the policy, the future, and this discussion overall would need to probably be headed. And to talk about that future, we have some absolutely fantastic names. In fact, I was looking at the bios of the gentlemen with me, and I'm fascinated to hear from them. And I'm really hoping to learn a lot as well from these gentlemen. First up, we have Dr. Satya Gupta, who is the president of VLSI Society of India. He's been in the semiconductor industry for, I think, best part of 30 years, both in India and the US. He has led various aspects of semiconductor industry, including design, manufacturing, IP development, CAD tools, and a whole bunch of associated industry and academic ecosystem. I think he's been one of the most ardent champions of building the semiconductor product design and manufacturing capabilities within the country in India. As a founding member of the India Semiconductor Association, I think back in 2005, he's been part of multiple policy initiatives. I think he's a serving president of the VLSI Society of India, which is the largest platform dedicated to building industry academia connects. Welcome, Dr. Satya. We also have Professor Kamakoti, who is the director of IIT Madras. He's a well-known name as the he's member of National Security Advisory Board, designed and India's first indigenously developed microprocessor Shakti. He was appointed the chairman of a task force, for leveraging AI. And I think it's safe to say that IIT Madras has been at the forefront of interdisciplinary research, and Professor Kamakoti has been at the forefront of leading that from IIT Madras. Welcome to you, Professor. We also have Raja Manickam, who is the CEO of Tata Electronics OSAT. He also founded TESOLVE in 2003 with the vision of creating a leading productization company, delivering high volume manufactured products from physical silicon, brings a unique experience encompassing the entire chip development process, from running manufacturing to managing product lines and building up startups around this important sector. Welcome to you, sir. We also have finally Sagar Sharma, who calls himself a trained engineer but a social scientist at heart. A senior investment he's currently a senior investment specialist for the electronic system design and manufacturing sector at Invest India, which means that he has been involved closely in the policy formulation around the future of semiconductor manufacturing in the country. He was also involved earlier in the Ministry of Education. He has been a key part of the team that was behind the National Education Policy of 2020. I think it's suffice to say that these four people can give a great idea of where we are headed in terms of semiconductor manufacturing in this country. How I'd like to structure this conversation, I would ask each of you to give an opening remark of 4 minutes each, and then I'll ask a bunch of questions after that. So let's start with Professor Kamakoti for your opening remarks, sir.
Nirmal, am I audible?
Loud and clear.
Yeah, very good. Thank you. So this year has been a great year. Of course, we had to have the COVID crisis to realize many things. In spite of a lot of bad things that happened because of COVID, but COVID has taught us many things about digital electronics and its use. This is where I think we could actually reframe the syllabus of digital electronics with a lot of case studies that COVID has actually taught us. We are now having 3 important things as we believe that COVID has to go off and it will go off. I think we are now having 3 important things where the convergence of 3 important things. One is the need. Now we have tremendous need across different disciplines, starting from A for agriculture to O for ocean engineering. Everywhere there is a need for electronics and semiconductors. We have a need for processors, we have a need for sensors, we have a need for advanced packaging, we have a need for making very compact devices, we have a need for low power, we have a need for everything. Everything that is part of a syllabus of a MTech VLSI design, those needs are practically coming up, and that is going to be the very important thing. The second thing is a variety. Now it is not the case that I'm making one class of system and trying to map multiple applications onto that system. Now there are different classes of systems with different needs and different configurability, and that has posed a very interesting problem, and particularly the RISC-V that we are talking of. The reason why it is actually becoming quite popular is because of this extensibility, where we can add a new instruction, we can add an accelerator without actually touching the decoding or anything that extensibility that we are talking of. I think variety plays a very important role. So the need plus the variety, which essentially gives a lot of confidence for startup companies to see they can make a semiconductor business in India and strive. And that is one second thing. And the third thing is the policies and support. The policies and support, the semicon policy that has just come up, the deployment link incentive policies that have been in place and now given a fresh look. I think these are also coming up and trying to align itself. See, when these come in isolation, unless these three align themselves, we cannot see a big mega result. And I think when these three have come together, I think this is the point we will see a big mega result. And we also see a lot of basic building blocks, specifically in terms of designs being done in India. Crucial, it was not just when I started a career in industry, it was all verification in India. Today, crucial design decisions are made in India, and those building blocks are there. And then we have also made a small but very significant dent in that telecommunication. Our 5GI as a standard essential patent has gone as a standard, is now in the part of the international standard. And we are now making more things into the standards itself. And then lot of other basic building block efforts that like the India Microprocessor Development Program and a lot more of software development, many separation kernels that are coming up. These are all very, very important building blocks that are going to give us a very good inroad into the industry. And that is something which is going to be the foundation for this need, variety, policy and support. So now the whole thrust has to be that how do we create the human capacity to handle a large variety of requirements in the country, plus how do we set up the infrastructure, specifically starting from fab plus ATMPs. Of course, we have people like Mr. Manickam who can talk many things about that. How do we quickly ramp up and converge and take it to the next scale? So this is of very, very high importance. So I always call this is now a real-time system. A real-time system is one where the answer should come, but the answer should come in the correct time, right? If you miss the time slot, it's gone. So we are in a real-time system mode, and we need to really get the acts together, and that's going to be the challenge, right? Thank you, Nirmal.
Thank you, Professor Kamakoti. I think part of the narrative can easily merge into what our next speaker is going to talk about. I think I call Sagar to the stage because I think he can put spotlight on some of these issues and how the government is essentially shaping the future of this of some of the questions that Professor Kamakoti has talked about.
Yeah, thanks, Nirmal. It's a privilege to be part of this, esteemed panel, comprising of stalwarts from academia and industry. And Nirmal, I'll tell you the program, which Government of India has come up with, which we call the Semicon India program for the development of semiconductor and display manufacturing ecosystem in the country. And it has been, it is a reality because of the support which we received, from the industry and the academia. So we constantly engage with the industry and academia, like Raja, bit Satya or Professor Kamakoti, So, and now I'll give you the brief, how this program is and what this program exactly is. And also, just for the audience purpose, I'll also give a brief context about what semiconductors are, So basically, semiconductors and displays are the foundation of modern electronic devices, and they contribute significant to the total bill of material of any electronic product. So, the government, is building on the success of, you can say, the Make in India program and the Digital India program. And now we have the Semicon India program, which aims to establish the facilities to manufacture the semiconductor products like semiconductor chips, integrated circuits, microchips, displays, etc. in India. These microchips, integrated circuits, etc., are integral part of modern electronic devices like mobile phones, cars, washing machine, cameras, aircraft, TVs, etc. And we will manufacture these products in this manufacturing facility. So hence this program will provide a boost to domestic manufacturing capabilities. It will reduce the import dependence, will promote exports, And overall, it will have a huge multiplier effect, across different sectors of the economy, with deeper integration to the global value chain. And this program, offers an incentive of roughly around USD $10 billion, which is a very, which is globally a very competitive incentive package. And this program aims to promote higher domestic value addition in electronic manufacturing, building on the success of the earlier scheme, which is the production linked incentive schemes, where the incentives have been provided based on the output. So now we are, having, aiming more deeper and more value addition from our domestic territory. So hence contributing, achieving a USD 1 trillion digital economy and a USD 5 trillion economy, by 2025, which paves the way for India's technological leadership in these strategic areas of strategic and economic self-reliance. Now, how we did it, this exercise, the policy on 15th of December, which was, approved by the Union Cabinet, was a result of a massive consultation, which we started from the exercise of expression of interest from on 15th of December, exactly 1 year before the policy got announced or approved by the Union Cabinet. So we started the exercise on 15th of December 2020, where we opened the expression of interest for different players to submit, to gauge their interest in the Indian market. So for both the silicon CMOS categories, the compound semiconductors, and the display fabs, and based on those massive consultations and our understanding, so we came up with this $10 billion incentive package. So, but the entire Semicon India program is not only about this incentive package. It also talks about the infrastructure support. There are two words which are very dear when we talk internally in the system. One is the ecosystem, and another is roadmap. And the kind of support which we have received from the leadership at the highest level, including the Prime Minister and both the ministers, being the techies, and the executive leadership comprising of Secretary Sahani and Joint Secretary God, it's sort of gave us a lot of enthusiasm and energy and that vigor and that rigor to enable this policy. And now we are really committed for this long-term vision. We have this medium-term plans and short-term action plans to enable this. Be it having the 85,000 semiconductor professionals in the next 5 years, or be it having a silicon fab, a display, two display fabs, the compound semiconductor facilities, the design ecosystem. So we are targeting the different components of the semiconductor value chain, starting from the design and up to the final packaging of the microchips. And apart from that, we are also very concerned about the overall ecosystem, be it the gases, the chemical ecosystem, the equipment supplier, etc. So in the coming years, you will see more and more maybe the capex mix of support or the other ecosystem support for the other ancillaries around the semiconductor ecosystem. We have set up the India Semiconductor Mission to derive the long-term strategy of the Semicon India program. So this mission will be led by the semiconductor experts and the industry expert, and will have great amount of autonomy, financial, operational, to execute the vision of the Semicon India program. So I just wanted to give you the highlight and put across the overall program of the Semicon India.
Wonderful. I now call upon Raja Manickam sir to give an overview, and I think he will be an important part of this entire thought process, even within the government and beyond, and executing on some of these as well, right? So over to you, sir.
Thank you very much. I think and I'll focus more on the manufacturing, but just at a very high level. Professor alluded to it, plus the earlier talk, right? I think it's a Y2K moment for semiconductors, right? What happened, right, during the Y2K. Right? A lot of the IT companies, basically exponentially, grew, even though ultimately the Y2K was not a real problem, but yet, it was a catalyst for them to jump into this. In this case, I would say, it is a real, the demand, right? Demand for semiconductor across the board, right? Is certainly going to be, doubling of the whole market and so forth. So, I always want to say, right, we from India are chasing semiconductor, but really, semiconductor needs India. Who can provide the kind of resource that the Prof was talking about, right? Across the board, right from the lower level labor to technicians to engineers, the innovation, the design, right? If the market is going to grow from $450 billion to 700 or 800 billion dollars, right? Where is the resource going to come from across the spectrum, right? So I think India is an answer for that. So I'll just focus more on the manufacturing piece of it. That's very dear to my heart. I personally have been a manufacturing guy. I worked in factories in Asia and at different stages. So certainly I do feel that we missed the boat earlier, and almost to a point where I did not believe that we will ever get to manufacturing. But I think I've been converted since the last year or so that this time it's real, right? And my colleagues that I interact with also believe me these days. And I think Tata coming into the picture as one of the early proponents, right, of semiconductor, right, is a testimony that we are certainly going to get into this, right? Because you do need someone large like that who's got patience, from a business standpoint, right? It may take 10 years to or so, from a financial recovery to say this is a long-term country mission, right? Ultimately, that you want. And I think it's all even for global, right? I think manufacturing is certainly, as most of does provide a very strong cycle of feedback of what can be done and what cannot be done, right? I will just give you an example, right? If you look at packaging, it has not been able to keep up with the fab technology, right? And then fab technology has to keep up with the design capability that we have, right? So certainly, we have a lot of design capability in terms of both, from a technology as well as people and so on. And then you've got fabs, right? So fab is able to implement most of it, but not all of it, right? So there's always a catching up to do. And then if you go further down the supply chain, right, with the packaging, right, I think they're very, very far off, right, in terms of providing, keeping up and keeping up and giving a good solution, whether in terms of power or speed or all kind of things, right? So and that innovation, right, I think we are certainly primed for it, right, India, right? Because a lot of customization is going to happen, a lot of design is going to happen. And with the manufacturing, it has to have that manufacturing piece of it, right? We make it manufacturable. So I'm very, very excited. I think this is going to be real. And there's the whole ecosystem is going to get built around it. So that's even more exciting, where, you can have startups, someone from a Prof's group can branch out and, start a, very sophisticated digital design and so on. And then we in manufacturing will work hand in hand with them, to make it real. So very exciting times, and I think this is a great time to be in semiconductors. It's very sexy again. Since I joined in the early '80s, when it was just starting up and then kind of went through a flat pace, and I think for India and for the global semiconductors, exciting time. Thank you.
Thank you so much. I think, look at the words that are being used, like ecosystem, bridging the gap, semiconductors is sexy again. This time it's for real, right, Dr. Gupta?
Absolutely, Nirmal, and thanks for everybody joining. First of all, let me give my perspective on the policy which is announced. 2 seconds. We have looked at the policies from all the countries in last 2 years or earlier. I think in terms of the quality of the policy, I think this is by far the best policy in the world, not just in India, or I cannot say one of the best, it is the best. No country has given a 50% incentive for semiconductor manufacturing so far, right? And in my earlier conversation, I said, right, when I was talking to a global friend, he said, if government can give 50 cents for a dollar put by the industry, that will be great. But we ended up matching dollar for a dollar. If industry is putting a dollar, government is putting a dollar. This is unseen of, unheard of, right? So I think this is by far the best policy in terms of the quality of the incentives, right? Second thing I would like to say is that a lot of people talk, oh, this is basically happening in last 2 years, we missed the bus and so on and so forth. But I think people like Professor Kamakoti, Raja, me and other people, we are basically building momentum towards this basically final finale for last 15 years, right? And as we say in semiconductor chips, right? When you tape out a chip, you tape out a A0 version, right? A0 version doesn't work always, right? Then you go to stepping B, stepping C, right? So we are basically in the process of stepping. Now we are stepping C, which is basically going to go to the production now, right? Just like the chip goes into production in Series C tape out, I think we are going to go in production. Now, talking about, I think policy is great, momentum is great. Professor Kamakoti established the need for semiconductor. But if you look at the fulcrum of the industry, it basically revolves around product design. Okay. Product design drives the manufacture, product design drives the research, product design drives the capacity building, right? So I think we need to find ways of leveraging India's existing design capabilities, both in industry and academia, right? From industry, we need a lot of people to take this opportunity, come out, create innovative products, and not just create the innovative products. Semiconductor industry is all about scaling. So they need to take it to scale. On the academic side, we have developed a lot of good technologies. Now it's time to take those technologies from lab to fab. I think we need to make it count. Third thing I'll say is that the talent development, I think both Raja and Professor Kamakoti alluded to this. We had earlier estimated that we will need about 85,000 engineers in next 5 years. But because of the global demand increasing and India is pushing the policy, we will need almost 200,000 or 2 lakh VLSI design engineers in next 5 years, more than double of what was thought of earlier, to serve both domestic and global demand. And on manufacturing side, we need to create at least 10,000 skilled technicians who can run our fabs, ATMPs, and all the other things which we are going to build, right? So I think it's time for call to action. As Professor said, real-time action. And I think we are all ready for it. Government has done its job. Now industry, academia, research, and the global collaboration, right? Because one thing you have to see is that global Indians are at the center of this industry, driving almost all companies, be it Western Digital, be it Micron, right? I think we need to leverage the power of the global diaspora and involvement of global Indians in driving this basically mission to make India a semiconductor nation. Thank you.
Wonderful. I think the first question is for Sagar. Now that the policy has been announced, that there have been, I think, 5 proposals that have come in for manufacturing, what are the plans of taking them forward in terms of implementation and actually starting manufacturing?
Thanks, Nirmal. Yeah, actually, we have received 5 proposals for setting up the semiconductor CMOS facility and the display facility. As you must have read in the press release, one proposal is from Vedanta for silicon CMOS, and other from there's a group called IGSS, Singapore-based group, and another from the ISMC group, which is India-based, along with the Tata Semiconductors. And there is two applications for display. One is from Vedanta again, and the other application is from LST Group, which is a subsidiary of Rajesh Exports, which are into the gold related manufacturing business. So yeah, now the next steps, the India Semiconductor Mission has already been set up with Joint Secretary Saurabh Gaur as the interim CEO, and the India Semiconductor Mission is mandated to do the technical and the financial appraisal of all the proposals which we have received. So that exercise has already been started. Of having the financial and technical understanding and know-how about each of the proposal. There will be negotiations with the applicants, to understand what they are trying to do, what kind of technology they are bringing, the feasibility of their project, etc., etc. So there are dedicated teams for this within the India Semiconductor Mission to take care of the financial and the technical appraisal, and probably in the next 6 to 8 months. That's the kind of timeline which we are looking for, to finalize and award the incentives, which are, for example, for the silicon and display, the incentive is of the order of 50% of the project cost. And the most important thing, Nirmal, which I want to highlight again, this time these incentives are pari passu, sort of upfront incentives, rather than the earlier times where the incentives are on the reimbursement basis. These incentives are upfront basis, and apart from the financial incentives, we are actively discussing with different states, government, etc., to provide other support with respect to the land, with respect to the power, electricity, which are the integral component of any semiconductor manufacturing facility. We need redundant power, we need absolute semiconductor grade gases, semiconductor grade chemicals. So how we'll build up the entire ecosystem. So that exercise is also going on parallelly. So I think I'm quite hopeful that in the next 6 to 8 months we'll have something very fruitful coming out for the country.
I think Raja would be extremely happy to hear that. Tata Electronics has been working on various aspects of the electronics and semiconductor supply chain. How do you see the commercial prospects of ATMP manufacturing in India? You're on mute, I think, Raja.
No, see, there always has to be some commercial aspect, right? The only thing, the expectation of, returns and so on cannot be the, what the venture capital or someone would require, right? So a very stable, long-term approach. So Tata is one of those, if something you want to see to create something new, right? Tata has always been a champion of that, right? So you need something like that. And I do believe that, you need something large to come in, right? In manufacturing, right? It's being controlled by a few companies in the world, right? Either it's captive or, you look at TSMCs of the world, right? So there is 4 or 5 fabs in the world that basically, run the entire semiconductor manufacturing. And then you got the OSATs as well. You got the top 5 or so control almost 70-75% of the OSAT business as well. So it's a very, very high investment and so on, right? But I think we miss, there's a few myths about manufacturing. One is, there is always this myth about, you need to have a market in order to start manufacturing, right? It really is not, right? You look at where the fabs are, right? The fabs are not really in where the market is, right? You go to Taiwan, right? Taiwan is a very small market, right? They basically are export oriented. Same with, Korea, right? The only one closest would be China, but even China, right? Their whole intent was when they started is to, again, export, right? So I don't think, you need to justify with the market, right? But in India, we do have a market, right? We do have a market. And we have every aspect of the ecosystem except manufacturing, right? And then within manufacturing, there's another ecosystem that goes around it. But if you look at design, EDA tools or any of the other things required, right? We are very, very strong. And whether, and you got the service companies that, support this as well. So really, we do have all of those things, right? So if you look at it, if I'm need to make a decision on where to put my next factory, right? What would I look at, right? I would look at the labor, right? We have infinite labor, right? Infinite labor, right? Especially in the lower level, certainly, and even in the technical side of things, right? And it's not new to us, right? We have been designed and we technicians and so forth. So I think and I don't see any other country even coming close to this. right? Now, the other aspect, interesting thing, I was talking to Global Foundries, and they were talking about a virtual fab, right? And I thought virtual fab means, is really, you just do the design and someone else will do the fab. But what they were talking about, running the fab virtually. So you have engineers and so on, right? It's a lights out fab, and then, you run it virtually, right? And then, so where does that talent come from, right? So again, right, we with the kind of depth and the scaling that is possible. So I think, besides money, right? And in fact, money is the cheapest thing these days, right? There's money sloshing around everywhere, right? So, people making announcements, 100 billion, 50 billion and all, it seems to be, everywhere, right? So money is really not the concern. Really is who is going to build it, who's going to make it, right? So I think that is the strength we have in India. And I think, once we have a start, right? I mean, the problem is always a starting problem. Always have a starting problem. So I hope, right, with Tata or, Vedanta and, all these guys, we seed it and we cross that first hurdle, right? Saying that, look, it can be done, right? I absolutely believe it can be done. There's no doubt in my mind it can be done. But, it has to be, proven to some people. Then I think, it will just take off. So my view is, it's not just a financial view, but I think it's the right thing to do. And a lot of the MNCs or, a lot of Indian based companies, are all, looking into this seriously now. 5 years ago, 4 years ago, when you talk about manufacturing, they will just run away, right? It's easy to make money from engineering services, right? And there's a proven model. But I think, they all think that, financially also it does make sense, right? It does make sense, but it's a different, trajectory. So I think we're in a very, very good spot.
Absolutely. I think I second you completely on this. And part of the capabilities part that we already have, I think is the work that Professor Kamakoti has done. Just wanted to understand, Professor, you've done a fantastic job with Shakti and RISC-V. What are your plans to make RISC-V a national movement of sorts and develop commercial products around the RISC-V core?
Yeah, thank you. I think as Mr. Manickam had mentioned, the RISC-V was actually a study of how our ecosystem is, right? So, and as he rightly pointed out, minus the manufacturing, even we did a small manufacturing at 180 nanometer at Chandigarh. Minus the manufacturing, I think we have a very strong ecosystem, including, building up of our PCBs, assembly, everything. I think that has the biggest confidence, because making a design is one part of the story, but ultimately, as Satya said, no, everything is centered around products, and we need to have those products. Now, coming to RISC-V, we strongly believe, and that belief has pushed us so far, that RISC-V will be the architecture of the future. Just because it is extensible, just because it has a very, very robust tool chain, just because we can quickly get a very highly sophisticated, at the same time, tailor-made, customized processor for an application. And I'm sure no other ISA as of now can bring. And other important thing is that since it is from the scratch, now a lot of security features are also getting built. For example, the hypervisor, which just got fleeced, I think it's a great one, and we are very upbeat on that particular aspect. Now, the first step towards commercialization, we really wanted how this design will fare on multiple class of application, and that's why MIT helped us in a very big way by putting the Swadeshi Microprocessor Challenge, where we had 1,000 teams in which around 30 finalists came, and then 10 people were given very good prizes, and we are nurturing them to make a startup around the RISC-V processors, both from CDAC and IIT Madras. Now, we now have shortlisted around 15 to 20 different applications, and we also have identified some startups plus big industry who are ready to take up these chips and build the applications around it. And we also see a very good interest among even the big multinationals, though I don't want to name them, who have come forward to look at our RISC-V program, and we have started that interaction. And overall, we believe that given the customizable architecture that we have, and the type of quick development needs of the different application sectors, we are very confident to release around 6 to 7 chips in the next 2 years, which would be into the market. And that is what my strong belief is, and we are working very, very fast on that. So probably next VLSI 2023, we will have some very good, I can come with some chips in my hand. Okay.
Fantastic. We hope to host you here, to unveil it at the VLSI that year. Questions for
Ashwini ji, Kama will be the next person basically holding wafers and the chip in his hand and doing a press conference, right? So,
fantastic. Fantastic stuff. Dr. Gupta, this is a follow-up to something that Raja Manickam had mentioned. For semiconductor manufacturing to be successful, the general consensus is that there has to be local demand, right? What is your perspective on semiconductor demand locally and other factors that will make having fabs in India successful?
Thanks, Nirmal. First of all, I want to ask Raja, all this money floating around, right? Me and Kama need some of that money. Please give it to us, right? So to do our coming to success factor of any semiconductor manufacturing, right? First of all, the investor and the team which is putting up the plan, right? They know what to be done, how to be done. Okay. So we should leave them alone after basic due diligence to do their work, right? And not get into what to do, how to do, don't do this, don't do this. I think that's their expertise. They are putting big money around it, so they know what to do. First of all, we have to leave them alone, right? As an ecosystem of the government, industry, academia, we have to create the enabling conditions for them to be successful, right? So some of the things what Kama talked, some of them Raja talked. I'll take a slightly different tack on it, right? Just from a foundry, we are not basically building an IDM or memory fab, right? We are building a foundry. Foundry needs somebody to basically put their design and buy large number of wafers, right? So while basically we are working very hard to create startups and all those things, right? It takes a while for startups to scale to the level where basically they will be able to consume large number of wafers. So typically, whenever I basically talk about this subject, first thing I say, go with the 80-20 rule. Okay? So 80% wafer consumption has to come from the global and 20% has to come from the local, right? If we say that we are going to fill our fab 100%, 80%, 90% from the local demand, I think we'll be doing injustice to the whole success of this story. We have to go with 80-20 rule, right? Second thing is that initial large demand till our startups become large, right, has to come from the two sources. One is basically we have to convince the large fabless companies and give them the right incentives to come and utilize India fab. So people like Qualcomm, Broadcom, or any of the people who consume large number of wafers, right? They have to come and basically start consuming the wafers, right? Second is that we have certain products which are of national importance, right? So, for example, education tablets, right? For example, LED lights, for example, smart meters, right? Now, these technologies are such basically where these are established products, so you will not get a startup type of the funding. So country has to basically identify about 10 such chips and develop them at a commercial scale in very short manner with full government support in a mission mode. Okay. So in 2 to 3 years, we should be able to produce a globally competitive in technology and price a product. Because if I create a LED driver chip, which is basically 2 rupees more than what they are buying today, nobody is going to buy from me, right? So we need to create these basically 10 products at a basically commercial scale, commercial pricing, best of the technology to create initial volumes for these fabs till our startups scale to the point where they start filling up the fabs, right? So we have to go with maybe 3-step approach. First, basically do a low-hanging fruit products, and one such example is basically LED driver, okay, and there could be others. Then in the medium range, we have to convince the global, basically big players to come and fill up our fabs, Qualcomms and Broadcom. And in the third stage, basically we get our own startups to have enough volume to fill up our fabs. So I think that product ecosystem which will consume the wafers, I think that's most important in making a fab successful, because we can build the fab, we can run the fab, we can do all of those things. The biggest problem any fab is that how am I going to get 90+% utilization of my wafers, right? And that's where we as an ecosystem can help both the government and the investor to provide that basically support in getting the products into the fab, which will make their capacity utilization happen.
Right. Sagar, I'm curious, while this is being implemented, we also have to look ahead, right? What would be the shape of India Semiconductor Mission 2.0?
So yes, to be honest, the India Semiconductor Mission, Nirmal, is the heart and soul of this entire endeavor. That's how we envision India Semiconductor Mission. So just to tell you the current status of the India Semiconductor Mission, it has been set up as the independent business division of Digital India Corporation, which is a Section 8 company of Ministry of Electronics and IT. And right. It is an independent in the sense of in terms of finances, autonomy, etc., and having that kind of authority to drive the entire Semicon India program strategy for the country. So basically, right now, as I mentioned earlier, the joint secretary is the interim CEO, but we are active. Like the leadership will soon notify the leadership team, which is a person of global stature in the semiconductor network for as the CEO, supported by a CFO and a CTO. That will be the core team, and then there will be team of directors and the managers will actually a team of around 30 to 40 people who will actually drive the entire strategy. And so basically apart from doing the technical and financial appraisal of the proposals and and coming up with and awarding the incentives to particular players in different categories which the program has announced. So this particular mission will actually drive the long-term strategy in terms of figuring out the right kind of technology, right kind of priority, as all the panelists have emphasized on identifying the products, what kind of, because ultimately the idea is to own the product. So if you really want to control the supply chain, the best thing is to own the product, to have our own Indian products, and that's the sort of the idea. We are sort of if you see the progression by the government, we started from the PLI. Now we are getting deep into the value chain. So the idea is is actually to own the products, and this team will be the central. The ISM will be the sort of the nodal agency for all these endeavors. So right now how we are going about is that we are setting up the working groups within the ISM for different things. For example, there is a working group on capacity building and the skill development. There's a working group on the equipments, on the design side, on the silicon CMOS, on displays, on packaging, etc. And these people are the experts in their respective domains. So they will bring that knowledge, that know-how, that due diligence for the entire ecosystem. How as a country we can sort of prioritize and address different sectors. So that kind of working groups are being set up within the India Semiconductor Mission, apart from getting the global leadership. And then there will be for example, I'll sort of just deep dive in one of the working group. For example, the capacity building working group. Okay, so the target is to get, by the time in the next 2-3 years we'll have a semiconductor fab, we should have a sustained pipeline of highly skilled manpower. And we need manpower at different levels. We need PhD scholars, we need managers, we need these shop floor workers. So we are sort of segmenting this manpower, and we are making tailor-made courses. We are sort of for different needs of the semiconductor industry. So the AICT is another partner. Ministry of Education is quite involved in this effort. Similarly, we have Electronic Skill Council of India. We have people from industry. We have people from institutions like IMEC and ITRI to sort of to give us the entire overarching effort in terms of the capacity building. So that's how we are planning to address different components of the semiconductor ecosystem within the India Semiconductor Mission. Nirmal, yeah,
fantastic. Fantastic. Raja, I think Sagar touched upon an important point in this narrative, right, which is skilled ecosystem, getting people in. Just wanted to understand what is the nature of the skilled workforce that is needed? What is the nature of the infrastructure that is needed? How are we going to meet this demand? Are we really ready for it?
Yeah, yeah. So, I mean, on the OSAT side, right, obviously there is quite a few on the low-level labor, right? Now, again, right, most of this equipment are highly automated and so on. So it's not rocket science really to operate this equipment, right? So because a lot of automation is already in there, right? And that's why, you see countries like Malaysia, Thailand, and all that able to, make this OSATs, right? I'm just talking about the OSAT side before I go to the fab. And then you have, the technicians, which are, again, the quality of the technicians that we have, at least the base, right? And then you train them up, I believe, will be more than, sufficient for us, right? These are people who do the setups, maintenance and, those kind of things, right? So, and then you get a bunch of engineers. Fortunately for us, right? Fortunately, really fortunate for us, there's a lot of Indians, in the diaspora who are working in key positions in Southeast Asia and other parts of Asia. Actually, hands-on people working on, wire bonding or mold or dicing or all kind of things, right? So we have factory people, that are, will just come to India, they're just dying to come back to India, right? Right, and so I think we're very fortunate in that sense, right? Most countries did not have this kind of benefit, right? So even though we say that we are starting, right? We really are not, right? We already have a running start in that sense, right? We do have the people that will come and then, you train. So I would say, the skilling, at least on the factory side, is not it's not impossible to do, right? It's certainly, within our reach. And the only difference I will say is, obviously, if you look at Malaysia or Philippines or Taiwan for the matter, right? They started in the 70s and 80s, right? So so a lot of it is tribal knowledge that you build over time, right? Factory is always like incremental, learnings you have, and then, you have, feedback within the factory, and then you go, and then, 0.1% yield, those kind of benefits you see, right? So we are certainly starting at a lower, productivity and quality or yield and so on, right? So there is going to be a learning curve to get to that level, right? So that is, will certainly take time. And yield, as you know, right, is very, very important in semiconductor, right? Very, very, very important, right? And especially OSAT, where you are the last step before you ship, right? Test and ship it. The cost of yield loss is is multiple, right? So the die and wafer cost and all that. So I think it's not not that it's not doable. And the good news is I'll give you a very good example. Orissa, I was in Orissa in Bhubaneswar, and they have something called a World Skills Center, right? World Skills Center, very nice building, right in the middle of Bhubaneswar. And world class, right, for the vocational training. And they have partnered with ITE in Singapore. ITE in Singapore is equivalent to the ITIs we have in India. And they've taken those people and they've given them a platform to build on this. I was so astonished that this is being done in Bhubaneswar, right? Who would think Orissa and so forth, right? And I met a delegation from Singapore there, right, who are also teaching and so on, right? So I asked them, right, what is the difference you see in the quality of people? And they said the quality of people, the hunger for them to learn, and the innovation, just the basic innovation thinking that we have, he said, they've never seen, in any other place, right? So we really have a big advantage, right? I don't think we'll be doing dumb manufacturing in that sense, right? So I call it engineering intensive manufacturing. So we're primed for it. We're primed for it. So I don't see a problem at all. Certainly, all the institutions will be involved at different levels. At the high level, the IITs for sure. and then that even the skill centers will be very, very, we do have an infrastructure. I mean, India does have a very good infrastructure in vocational. The unfortunate part is we don't recognize vocational as a good area to go, and I think semiconductor will give them that exposure. It's sexy to be in semiconductor.
Right. I think that connects easily to the next question, because my next question was going to be for Professor Kamakoti. Design the premier education institutions of this country has been at the forefront of this conversation, right? And how do we make the VLSI design activities more democratic? How do you push it all over the educational landscape of the country?
So, see, we had a wonderful, just before the semiconductor policy, there was a national education policy 2020. And there was complete stress on vocational training and what Mr. Raja says, right? So, and I strongly believe that we as a country are yet to tap the rural intelligence. Rural means the non-urban intelligence. And then there are a lot of skilled laborers and a lot of people with hunger, as he rightly pointed out, who would like to come and work very dedicatedly and try to push a lot of things which probably we think may not be pushable, but they could actually achieve lot of things, and I strongly believe in that. So from our end, we have started democratizing. See, this is always a question that we answer, right? Around 1.5 million people write JEE exam, right? And we give admission for 15,000 in the IIT. So what happened to the remaining 14,85,000, right? So this has always been a question to us. And one such answer that IIT Madras started is the online BSc degree. And now we believe that with the current cloud infrastructure and sort of the virtual fabs that we are, talking of, we could scale such type of online, not even degrees, but even diploma, and also involve the polytechnics in a very big way, and also catch them young, like plus 2 pass, but then they like to go and do a skills development, or in the mid of the degree, to come and start working on this type of what we may term as an sort of applied electronics or applied VLSI design. And I think we now have a framework which can also not only just teach things, but also can give a sort of a much more intensive lab environment over the cloud. And then we could set up certain skill set facilities in the polytechnic, or we call it as technology centers, where they could come and do some work to understand the more intricacies of this. And I also feel that there could be a lot of augmented reality and virtual reality based things which can give a lot more of training towards the end product. And then finally there could be something which the company or the industry that hires them can give a little more training and make them productive. So from the time where we give the diploma, time they recruit and make them productive, the time gap we can reduce it to say a month or so, while massive amount of training can go on a AR, VR type of platform, while the actual hands-on can be given by the industry, but they will be very much fine-tuned to take that hands-on and quickly ramp up. So these are some of the ideas where we talk of scale and democratizing VLSI design. And you may be knowing that the MIT has a program called Special Manpower Development Program for VLSI, and we are into the next phase. And in this phase, we are basically looking at cloud-based infrastructure for the tools. In the previous versions, avatars, we had individual tools installed in the academic institution. More or less only the students of the academic institution had access. Now we are looking at a cloud-based infrastructure. So that also opens up a lot more of utilization, effective utilization of the license, and also more democratizing. It need not be necessarily to the enrolled institutions, but we can also scale it up to people who get associated to the institution. It can be like an hub and spoke model, where an institution which is enrolled to the SMDP program can adopt multiple other institutions, including polytechnics, and through them they can start having an access to the infrastructure. So I think we have learned, and the Corona also has taught us how to scale up these education. and I am very confident that capacity building we will never miss and take it forward. Yeah.
Right. We're really running out of time, I've been told. I need to wrap this up in the next 5 minutes, I guess. But before that, Dr. Gupta, are we poised to become a leader in semiconductor products area?
Absolutely, Nirmal. I think we have heard from all the panelists. In the morning, we heard Honorable Minister Rajiv Chandrasekhar. I think if I have to characterize this, right, in some way, and a lot of people talk about China. So I'll just take a parallelism with there, right? So what did China do? China first created a very strong manufacturing ecosystem, right? Then from there, they went to creating a leadership on electronics products. Okay. Look, earlier people used to say Chinese products are cheap, this, that, all of those things, right? Today, if you look in top 10 categories, 5 of the top 10 categories, Chinese brand are in top 5. Okay. So they took their manufacturing capacity, created a basically very strong brand and product ecosystem. And that product and brand ecosystem drove basically the semiconductor ecosystem, because once you have product, then you have a demand for basically semiconductors and you go and do it, right? Right. So now if I look at India, India has to follow the same path, but we have to lead with our design excellence, right? We are much ahead of any other country in the design excellence. From design, we have to go to the end products, like basically mobile phone, tablet, smart meter, LED, all those things, right? And if we have that product ecosystem, that will automatically drive the demand for semiconductors, right? So today, everybody talks that basically we have $24 billion of semiconductor consumption in India. So as a business person, we have to understand there is a difference between consumption and demand. Okay. If I'm starting a basically company, I will always look at what is my available market and what is my servable market, right? So if I'm putting a 28 nanometer fab, then this $24 billion is not available to me, right? A very small slice is available to me, right? So I think we need to clear-cut understand the demand and consumption, differentiate between them, set up the product companies. So in the top 10 consuming electronics product, we have at least 20 to 25% market share. Right now, it is less than 5% market share. That does not basically create a realistic demand for semiconductors. So while we are basically building semiconductor policy, all the relevant pieces and nuts and bolts, at the same time, we have to upscale our electronics product, Indian products, Indian brands, so that we reach 20 to 25% market share. And that will automatically drive the demand for the semiconductor manufacturing, make the people who are investing in this area successful, and all the 9 yards after that. Thank you.
Right. I have a whole bunch of questions that the audience has sent, but I think due to paucity of time, I'll take just one of them, and any of you can answer that. What do you think will make the Indian OEMs agree and interested in changing their existing boards with made in India pieces as opposed to say made in China or other imported ones?
Nirmal, I think it is already happening. If you look at the company like Boat, which created a brand and created a product, but initially they were manufacturing in India. Now they have signed up 2 ODMs in India where their products will be manufactured, right? So as I was saying earlier, the product ownership and product creation is basically the prime. Indian brands are prime. They will drive all the downstream ecosystem very well. So in case of Boat, it's already happening.
Right. Sam. Raja?
So, I'll give you an example, right? If you look at the EV market, right? EV mobility, right? A lot of the electronics, the modules and all that is being imported, right? So we don't have an OEM which makes it, right? But the electronics that goes into, whether 2-wheeler or 4-wheeler for the EV mobility, has got its own customized, requirement for India. Right? Just like, we need a different type of a shock absorber or something, right, for India, right, Indian roads, right? So, and then, the support in order to, make it more efficient from a EMI, standpoint, or, all the other things that the environment throws at them, right? So I think the OEMs, are starting to see the value, right? So the customer is now driving more value and saying, hey, look, I just can't import it from somewhere else, and it's become a black box, and I just can't put it into a car or a two-wheeler, right? So I think the value add that that OEMs are getting recognition now, right, is becoming more and more important. So there is a drive towards OEM manufacturing locally and all that, and I think on the OEM's part, right, they need to step up, right, put some into innovation, into learning, and not just buying and importing something and you put the brand inside. So.
Right. Fair point. I think this has been a very interesting conversation. I'll have to probably wrap it up. We are 10 minutes over the time limit. But just to sum up, I've been writing about multiple industries for all these past few years, and I've never seen so much optimism around one industry. There was not one note of dissent in among the four panelists. Everybody is aligned. Everybody is having this upsurge of optimism, and I think it's fantastic that we are finally having being put on the rails, and will be making, as Raja said, semiconductors sexy again. On that note, thank you all the panelists. It's been a pleasure talking to you. Thank you so much. Bye-bye.
Thank you.
Thank you, everyone. Thanks.